Hi everyone. Today we're going to study implicit differentiation. Let us first define implicit functions. Consider the following equations. Equation A, y equals x squared minus 2x plus 1. Equation B, x squared plus y squared equals 2. Equation C, y equals x squared plus y squared. We can see that the first equation has the x variable in one side and the y variable in the other side, whereas the variables of the second and third equations are mixed. The first equation here is called explicit function, while the two other functions are called implicit functions. From the beginning, we learn how to take derivative of explicit function. In this video, we will study how to take derivative of implicit functions. Let us now study this implicit differentiation. To find the derivative of an implicit function, recall the chain rule. The formula is d over dx of f of gx equals f prime of g of x times g prime of x. This time, we're going to let g of x equals y. So we have d over dx of f of y is equal to f prime of y times dy over dx. Let us see this example 1. Find dy over dx if x squared y equals 1. We have two solutions here. Solution A is by using rule of differentiation. First, let us rewrite the function as y equals 1 over x squared. Let us simplify further the right side, and this is equal to x raised to negative 2. Now the derivative y prime equals negative 2 x raised to negative 3. We can rationalize our negative exponent, so our answer here now becomes negative 2 over x cubed. This is our derivative. Solution B is by chain rule. In here, we're going to show that we're going to take the derivative of both sides of the equation. So we have d over dx of x squared y equals d over dx of 1. Please notice in the left side, we have two functions here. In fact, product of two functions. The first function is x squared, the second function is y. So let us write the product rule, d over dx of f times g. This is equal to f times g prime plus g times f prime. Applying our product rule in here, so we have x squared, we copy the first term, times the derivative of y, that is 1 times dy over dx, plus, we copy now the y. Then, the derivative of x squared is 2x. And this is equal to the derivative of 1. This is a constant, so we write 0. Simplifying our left side, we have x squared times dy over dx plus 2xy equals 0. This time, our purpose is to isolate dy over dx. We start by transposing these two xy on the right. The right side now becomes negative 2xy. Let us divide the equation by this x squared. So we have dy over dx equals negative 2xy all over x squared. We can see that we can cancel the x in the numerator and one of the x in our denominator. So we simplify this into negative 2y over x. There is a variable y here that we can simplify further. We can observe that based on our function here, the value of y can be equal to 1 over x squared. Let us use this value of y and substitute here. So we have now negative 2 times the quantity 1 over x squared all over x. When we simplify this expression, we will come to the final answer, negative 2 all over x cubed. Example 2, find dy over dx if 5y squared plus cosine y equals x. Let us show that we are going to take the derivative of both sides, as we see here. And then the left side becomes d over dx of 5y squared plus d over dx of cosine y equals d over dx of x. Let us now take the derivative of each of the functions. So we have 10y times dy over dx plus derivative of cosine y will be negative sine y times dy over dx equals derivative of x is 1. On the left side, we can factor out the dy over dx. So the left side becomes dy over dx times the quantity 10y minus sine y equals the right side, which is 1. Let us divide the equation by this quantity. So we will get the final answer of dy over dx. This is now equal to 1 over the quantity 10y minus sine y. This is our final answer. Example 3. Find dy over dx if y squared equals x squared plus sine xy. Let us show again that we want to take the derivative of both sides. But in here, we will simplify further our right side. So it becomes d over dx of x squared plus d over dx of sine xy. The left side is the same. Let us now take the derivative respectively. The left side becomes 2y times dy over dx equals derivative of x squared is 2x plus derivative of sine is cosine, and we copy the angle xy times the derivative of the angle xy. We will copy everything and then we will take the derivative of this xy, another product function. So we have the x times the derivative of y will be 1 times dy over dx plus the function y times the derivative of x, which is 1. We can simplify this derivative into x dy over dx plus 1. So we have the derivative here as a binomial, we will multiply each term by cosine xy. So it will now be x cosine xy times dy over dx plus y times cosine xy. We copy the 2x down here. The left side will just be same. Our next objective is to put all terms with dy over dx all in one side of the equation. Look at the left side. We have a term with the dy over dx already. On the right side, the middle term has dy over dx. So let us transpose this to the left side. So it will be like this now. And on the left side, we are going to factor out the dy over dx. And it will be like this. Dy over dx times the quantity 2y minus x cosine of xy equals the right side will just be same. So we want to isolate dy over dx. Let us divide the equation by 2y minus x cosine xy. So dy over dx is equal to 2x plus y cosine xy all over 2y minus x cosine xy. This is our final answer. Example 4. Find dy over dx given the function 2x cubed minus 3y squared equals 8. We can see here that we have three terms in the given function. First term, 2x cubed. This is a function of x. Second term, negative 3y squared, is a function of y. Equals 8 is a constant. We know how to take derivative of 2x cubed. Now for the second term, negative 3y squared, this is a function of y. In this case, we're going to differentiate this function similar to x function, but we are going to attach dy over dx. Then the right side is the derivative of 8. So let's begin. Derivative of 2x cubed is 6x squared. Derivative of negative 3y squared is negative 6y times the dy over dx equals derivative of 8 is 0. From here, we're going to isolate the dy over dx. What we'll do? First, the 6x squared we will transpose to the right. From positive, it becomes negative 6x squared. And still, we want to isolate the dy over dx. So, we're going to divide this equation by the coefficient of dy over dx. In this example, it is a negative 6y. When we do that, dy over dx will be alone equals the negative 6y comes as the denominator of the fraction on the right side. We can simplify further by simply cancelling the negative 6 in the numerator and denominator respectively. Finally, dy over dx equals x squared over y. Example 5. Find dy over dx given the function x cubed plus y cubed minus 9xy equals 0. We have three terms on the left side equals the right side is 0. The first term is a function of x, second term is a function of y. In that case, we're going to differentiate the y function similar to x function, then attach dy over dx. While the third term, we have this negative y coefficient times the product of the functions x and y respectively. In this case, we're going to use the product rule later. So let's begin the differentiation. Derivative of x cubed is 3x squared. Derivative of y cubed is 3y squared times dy over dx. For this negative 9xy, first we will put the constant negative 9 outside. And then we will apply the product rule to the x and y as a product. So we start with the x times derivative of y. The answer is 1 times the dy over dx. Plus, we copy the y, then derivative of x, which is 1, equals derivative of 0 is 0. Let us simplify this part now. So the negative 9 is multiplied to the first group and the negative 9 multiplied to the second group. The first group becomes negative 9x dy over dx. And the second group, negative 9 times y is negative 9y. And from here, we're going to group all terms with dy over dx in one side of the equation. Then factor out the common dy over dx. In our equation here, we have 4 terms on the left side. There are 2 terms with dy over dx, the second term and the third term. That means the first term and the fourth term we will transpose to the right side. 3x squared is positive, it becomes negative 3x squared. The negative 9y becomes plus 9y. And then on the left side, we factor out dy over dx. So we have the quantity 3y squared minus 9x is multiplied to dy over dx. We want to isolate the dy over dx. We divide this equation by the coefficient of dy over dx. In this case, we divide the equation by 3y squared minus 9x. By doing so, this 3y squared minus 9x becomes the denominator of the right side. So dy over dx now alone on the left equals negative 3x squared plus 9y all over this denominator. Note that there is a common factor in the numerator, which is 3. Common factor also in the denominator, which is 3. We can factor it out. But we can consider that we want x squared to be positive on the numerator. So instead of factoring positive 3, we can factor out negative 3. So we have negative 3 times the quantity x squared minus 3y in the numerator over the denominator negative 3 times the quantity negative y squared plus 3x. Then we can cancel the negative 3 in the numerator and denominator respectively. Finally, dy over dx equals x squared minus 3y all over negative y squared plus 3x. Example 6. Find dy over dx given 3x squared y squared equals 4x squared minus 4xy. We can see in our problem that we have 3 terms. 1 term on the left, 2 terms on the right. We can see that the term on the left is a product of x and y functions respectively. The 4x squared is a function of x, and the negative 4xy is again a product of the functions for x and y respectively. We know that we're going to differentiate y function similar to x function, then attach dy over dx. For the product functions, we will apply the product rule. So let us begin. On the left side, the coefficient 3 we can put outside. Then we apply the product rule to x squared, y squared. So let us begin. X squared we copy first. Then we take derivative of y squared. That is 2y. Then the dy over dx comes. Plus, we copy the y squared times derivative of x squared, that is 2x, equals derivative of 4x squared is 8x, minus the 4 as coefficient, we put it outside. We apply now the product rule to x, y. First, we copy the x times derivative of y, which is 1. Then we attach the dy over dx. Plus, we copy the y times derivative of x, which is 1. Let us simplify further. On the left side, it is now simplified into 6x squared y dy over dx plus 6x y squared. We know that the constant 3 is multiplied to each of the two groups inside the grouping symbol. Now, equals the right side. 8x we copy here, then the negative 4 is multiplied to the two groups inside the grouping symbol. So negative 4 times the first group becomes negative 4x dy over dx, then minus the second group 4y. Next step is we're going to group all terms with dy over dx in one side of the equation. Then factor out that common dy over dx. Look at this term. It has dy over dx. We will transpose to the left. Look at the 6x y squared. There is no dy over dx here, so we transpose this to the right. From positive, it becomes negative. So the next step, it will be like this. Now on the left side, we factor out dy over dx. So it becomes the quantity 6x squared y plus 4x is multiplied by dy over dx. And then let's isolate dy over dx. We divide this equation by the coefficient of dy over dx. In this example, we divide by 6x squared y plus 4x. If we do that, the dy over dx will be alone on one side. And this value here becomes the denominator of the right side. At this point, notice that there is a common factor in the numerator and in the denominator. In the numerator, the common is 2. We can factor it out. So 2 times the quantity 4x minus 2y minus 3xy squared over the denominator, the common here is 2x times the quantity 3xy plus 2. Now we can cancel the 2 and 2 respectively. So dy over dx equals 4x minus 2y minus 3xy squared over x times the quantity 3xy plus 2.